Ever wondered how electric vehicles keep their batteries from overheating? Managing heat is critical for performance, safety, and battery life, and that's exactly what thermal management is all about. Let's decode the science behind battery and EV thermal systems. Let's discuss how temperature affects battery parameters. The first one we'll look at is internal resistance. As we discussed earlier, internal resistance is the resistance to the flow of electrons within the battery's materials. This aspect is directly affected by temperature, and the graph here provides a general depiction of the relationship between temperature and internal resistance in a lithium-ion cell. As you can see, the internal resistance decreases as temperature rises. This means that at moderate temperatures, the battery becomes more efficient, allowing for better power output. Around 25 degrees Celsius, resistance reaches its lowest point, indicating an optimal temperature range for operation. This is where the battery can function most effectively with minimal energy loss. However, notice what happens when we go beyond 30 degrees Celsius. Internal resistance starts to increase again, even as temperatures continues to rise. This is due to thermal stress on the battery materials, which can lead to efficiency losses and accelerated degradation over time. Understanding this pattern is essential for optimizing battery performance, managing heat, and ensuring longevity of the battery. Next up we have is self-discharge rate. So let's explore how temperature affects a battery's self-discharge rate during storage. First, let's understand what is self-discharge rate. This refers to the gradual loss of charge in a battery over time, even when it's not being used. It happens because of internal chemical reactions within the battery, which slowly drain its capacity. This is an important factor to consider when storing batteries for long periods because even in storage they can lose a significant amount of their charge. Now looking at the graph, we can see how temperature influences this self-discharge rate. Along the x-axis, we have the storage duration in months ranging from 0 to 10. Then on the y-axis, the percentage of the capacity lost over time. There are three lines on the graph, each representing a different temperature: 25 degrees Celsius, 35 degrees Celsius, and 45 degrees Celsius. So as the temperature increases, the self-discharge rate becomes much faster. At 25 degrees Celsius, the battery loses capacity gradually, maintaining most of its charge even after several months. However, at 35 degrees Celsius, the rate of capacity loss increases significantly, and by 45 degrees Celsius, the battery's capacity drops much faster over the same period, almost up to 65%. This means that storing batteries at higher temperature leads to a quicker loss of usable capacity, which can shorten the battery's effective storage life. So, in conclusion, the key takeaway here is to store batteries in cooler environments whenever possible. Lower temperatures, such as around 25 degrees Celsius, help minimize self discharge, preserving battery capacity over long longer periods and ensuring the battery is more ready to be used when you need it. If you found this useful and want to learn more about how EVs, batteries, and energy storage systems manage heat, check out the full course in the description. Don't forget to subscribe for more insights into EV thermal management, battery tech, and cooling strategies.